Hola, mi clase. So we are moving on to 3.2 linear functions. So it says I can identify, evaluate, graph, and write linear equations. So the first vocab or key term is function notation. So function notation is a method for writing variables as a function of other variables. The variable of x is used to find the variable of y. And then linear function is a function whose graph is a straight line. So we have examples. So this is a linear function, y equals 2x plus 5. And then is the same as, this is called f of x equals 2x plus 5. And this is our example of function notation. Okay, so you can see that the f of x function when x is, right, what's the function when x is something, is the same as y. So y just becomes f of x. You'll see that if we have multiple functions, sometimes they'll have different letters. So it'll be h of x, g sub x, and so it's just so that we can have multiple functions. So this is our function machine. And so we're going to put in an x, do something with it with this equation, 5x plus 1, and it'll become f of x. So you can see it says read as f of x. So it says, how can you represent a function rule? Write the equation y equals 5x plus 1 using function notation. So again, all we do is we change the y to become f of x. I don't know why I just wrote a y there. And equals 5x plus 1. And it's just a way that we can say, what's the function when x is this? All right, so the cost to make 4 bracelets is shown in the table. How can you determine the cost to make any number of bracelets? So basically they're asking us to write an equation for it, right? So the very first thing we need to do is find the slope. So if we go this way, right, that's plus 1, plus 1, plus 1, right? What I'm doing is subtracting. So I'm taking 4 minus 3, that's positive 1, 3 minus 2, that's positive 1, and I'm taking 2 minus 1, that's positive 1. And so then I'll go this way. And so 62 subtract 47, I borrow, so what is that, 15, right? That should be what I get here, just in case. So 7 minus 2, right, 5 and 15. Those are both positive as well. And then I go this way and I get a positive 15. So then, right, we do our difference of our y's over our difference of our x's. And so our slope would be 15. So now I need to go and find my equation, or my y-intercept, right? I need my b. So we're going to pick one of our points. It does not matter which point we use. I always like to use my smallest one. So I'm going to use the point 117 to fill in my equation. So I'm going to take y equals mx plus b and fill in everything I have. So 17 is my y, slope is 15, my x is 1, and then I'm going to add b. So I get 17 equals 15 plus b. Inverse operations, we subtract 15, and we get 2 equals b. So now I have my b, and now I can write it as an equation. We're going to practice using that function notation. So f of x equals 15x plus 2. And there you go. So Tamika records the outside temperature at 6 a.m. So that's what this thermometer is. This is the temperature at 6 a.m. Okay, and I know it's really hard to read, so I'll tell you what it is. It says -3 degrees Fahrenheit. It's very, very hard to read. So here you go. The temperature increases by 2 degrees Fahrenheit every hour for the next 6 hours. If the temperature continues to increase at the same rate, what will the temperature be at 2 p.m.? Well, if this is our starting point, right? So this is our B, because that's where the temperature starts to increase at. And then it tells us that it's increasing by 2 degrees Fahrenheit every hour. That is our slope. So our function would be f of x equals 2x minus 3. Okay, because it's already 3 degrees below 0 when we start. So then we have to find out how many hours between 6 a.m. and 2 p.m., right? So if we have 6 a.m. here, we want to get to 2 p.m., we need to know what our x is, right? The number of hours. And that'll be our x. So 6 to 7, 8, 9, 10, 11, 12, 1, 2, right? So 6, that's 7 a.m., 8 a.m., 9 a.m., 11, 12, 1, 2. So I have 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 hours in between. So what we're gonna do is take that 8 hours and plug it into our function. So we'll have f of 8, because that's what we're checking. When is x, what is it when x is 8, equals 2 times 8 minus 3, or 1 plus minus 3. So this means I'm checking the function when x is 8, okay? That's what I'm saying, and so I plug in that 8. So I get 16 minus 3, and so 16, 15, 14, 13. And so the function after 8 hours is 13, okay? So we can then say the temperature at 2 p.m. will be 13 degrees. As long as this increase of 2 degrees continues past those 8 hours. All right, there's your answer. And then I also did this part, the function notation part right here, right? See if I can highlight it for you guys, this part, so that you can see what it looks like when we're inserting something. So that's what this is. So it says, what is the value? And that's supposed to say f of x, and I'll draw the little f on there. It got a little cut off for whatever reason. So what is the value of f of x, or f of negative 6, if f of x is negative 8x minus 6? So it's doing exactly what I just done the last one, except now with negative 6 in this equation. So f of negative 6 equals negative 8 times negative 6 minus 6. So we get positive 48, because negative times a negative is a positive, and 8 times 6 is 48, and then we're going to minus 6, so we get 42. So the function at negative 6 is 42. There you guys go. So you can see it's exactly like our equations, except we're just changing y to say f of x, or f of what. So the table shows how many pizzas Antonio's Pizza Shop can make in an hour. Complete the table, write a function to represent the number of pizzas Antonio's Pizza Shop can make in x hours using function notation. So make sure it says f of x. What is a reasonable domain and range for the number of pizzas Antonio's can make? So they don't have the table fully filled in, but you can see it says 1, 2, blank, blank, 5. So we can make this assumption that it's going up by 1 for every hour. So using that, we can then find the slope, and so we can decide what it would be, right? So this is plus 1, and this is plus 1, and then this would be, is that 18? 17 minus 8, right? 17 minus 9 would be 8. Yeah, 18. And then 9 minus 1 is 8. Yeah, 18. So I got the same thing both times. I'm just going to put them over 1. So 18 over 1 is 1. I mean, 18 over 1 is 18. So our slope is 18. So we can then use that to work backwards and to work forwards, right? So we would take 67 and add 18. So that's 15, 6, 7, 8. So we get 85 here, and then for the other one, we take 31 and we minus 18 to go the other way. So 11 would be 3, and then 2 minus 1 is 1, so this would be 13. We technically need to find our y-intercept, right? So let's use the smallest pieces of information that we have. So I'm going to go 13 equals 18 times 1 plus b. So 18 equals 13 plus b, and then we have minus 18. And so yes, technically our b is negative 5. So we have f of x equals 18x minus 5. That does happen. It's because they're not making, right, at 0, it should technically be 0, but because it's not that same kind of rhythm, it's a non-proportional, we have to deal with this negative at the beginning. I know it doesn't fully make sense, but, right, how do you already have less than? Are you in debt? But based off our information, that is our equation. So the second question says, what's the reasonable domain and range for the number of pieces? I'm actually going to have us discuss that when we get back and see what your guys' thoughts are on like what would a reasonable domain and range be, especially since this is a story problem. So we'll discuss that one when we get back. All right, so it says use the data in each table to write a linear function using function notation. So again, we need to find the slope and the y-intercept. So I'm gonna have you guys pause. It would be a really good idea for you to try this one on your own and see if you can get the slope and y-intercept on your own and determine if you can write it in function notation. Once you feel like you have, you are welcome to unpause and see how it went. All right, so we need to subtract. It doesn't matter which order you subtract it in. I just like to go up the table. Some people like to go down the table. It's completely up to you. So 1 4/10 subtract 2/10. This would be positive 1 2/10. And then 2/10 subtract 6/10 negative is 8/10. Okay, and right now we can't decide that this is not linear because we have to check this side. So 7 minus 1 is positive 6, and then 1 minus negative 3 would be positive 4. So we can already see that these ratios are going to be a little different. So we still do our y's over our x's. So we would take an 8 and put over 4, and we would take 2/10 and put over 6, and we would need to see if those were the same. This is 2/10, and 1 and 6/10 divided by that would be 2/10. So they are equivalent, and that's our slope. So then we need to pick a point. Doesn't matter what point you want to use. Again, I like to just use positives in my smallest numbers. So I'm going to use 1, 0, 2. So I'm going to go 0, 2 equals, put my slope first, 0 and 2/10 times 1 plus b. And so I get 2/10 equals 2/10 plus b minus my 2/10. That's inverse operations. We get 0 equals b. And so we would say function of x, f of x equals 2/10 x. And you do not need to put, sorry, I'm just trying to make my decimal bigger, d plus 0. All right, a function f of x equals 4x plus 5 has a domain of 0 to 50, positive. What is its range? So if we have the domain, a very specific domain, what can my x's be? The range would need to be in between there, would have to be based off this. So we're going to do the f of x at 0, and we'll do the f of x when it's 50. Right? Because that's the very first point and that's the very last point. So we would do 4 times 0 plus 5, and then we would get 0 plus 5, and so we would get 5. Then we do 4 times 50 plus 5, so we get 200 plus 5, so we get 205. So then our range would be 5 less than or equal to, because it was less than or equal to at the beginning, y, because range has to do with y, less than or equal to 250. right? If the x is our range, we then make our function at those points and find out where those points lie. Sorry about that. And we would then put everything in between it as well. So linear functions can be represented in multiple ways using words, tables, graphs, and rules. What is the value of f of x if f of 5 if f of x equals negative 7x plus 12? So that's your independent practice problem, but don't forget to finish this problem by stating what would be reasonable domains and ranges for this story problem. All right, until next time, adios. Where's my stop button? Everybody's watching me. There it is.